Hello guys and welcome to the channel. In this video, you'll be learning how attackers can trick or manipulate AI models or machine learning models into making wrong decisions or wrong predictions, just as I have here on my screen. So we have the original image to be 7, but then due to some modifications or manipulations, we've been able to make the model to predict this image as 3. Okay, so we call this adversarial attacks. So basically in this video, what we'll be doing is, one, we'll be creating a simple neural network. Then we will train the network on the MNIST dataset. Then we will use the FGSM, which is fast gradient sign method, to create adversarial samples. So basically, the fast gradient sign method is based on the principle of using the gradients of the loss function with respect to the input data. So this basically creates an adversarial sample that we can feed into the neural network that we'll build in order to trick the AI model. Okay, so then after using the FGSM to modify the test image, then we'll perform the evasion attack. Evasion attack simply means trying to not get detected by the AI model as false. Okay, so we try to evade the detection of the AI model. Then we compare the original prediction versus the adversarial prediction by the time we are done. Okay, so first things first, you need to install a few libraries if you don't already have them. We'll be using TensorFlow for this. So go ahead and install TensorFlow. In order to do that, you go to your terminal window. So you can, I'm going to activate my virtual environment here. So I'm going to activate my virtual environment. Then I'm going to install TensorFlow. TensorFlow is what we use to build the neural network. So pip install TensorFlow. So this will install TensorFlow for you. And if you already have it like I do, it's going to tell you that the requirement is already satisfied. So go ahead and hit enter. As you can see, requirement already satisfied. But for you, it's going to install TensorFlow for you. All right, this is basically what you need to do. And then we'll be using Jupyter Notebook to write the codes. All right, now move into your Jupyter Notebook. And for, just so you know, the link to this code will be provided in the description of this video below. A GitHub link to these codes will be provided in the description of this video. So first of all, we want to import the libraries. We want to import TensorFlow, import NumPy. Then we're going to import Matplotlib. This is what we'll be using to plot the graphs or the images. So go ahead and then hit enter. So that has imported the dependencies. Then we want to, remember we said we are going to create a neural network. So we are going to need train and test data in order to train the model. And to do that, we're going to use the MNIST dataset. So go ahead, hit enter. And then this is where we build the neural network. This is a simple convolutional neural network. So model sequential And this is just a straightforward neural network with a ReLU activation function and then the softmax for the outputs. Okay, go ahead and compile. So it's going to run 5 epochs. Epochs are like iterations. So the first time it will loop over the data, that is 1,875 training samples, then go over it the second time all the way to the 5th time. That's what is meant by this epoch here. So we'll be patient for that to happen. Remember, the link to this code or this script will be provided in the description below. All right, the third epoch, I'm just going to skip ahead to when this is complete. Already, you can even see the remaining output here, but I'm just going over this just to show you how everything is done. I've already run this code before now. All right, so the 5 epochs are completed. The next, we want to evaluate the model first and foremost. This is done using clean data sets, not a distorted data set yet. We just want to evaluate the performance of the data of the neural network. So to do that, we use this block of instructions right here. We compile. And as you can see, we have an accuracy of 97.67%. All right. Up next, we are going to use the FGSM, which is fast gradient sign method, to create a distorted image sample, which we are going to use in demonstrating the adversarial attack. So you can copy the code, paste, and then hit on run. When that is completed, then we now run to compare the prediction of the normal image versus the adversarial image. What we're going to do now is we are going to, as you can see here, we have original prediction, which is predicting on the normal sample of the image without the FGSM being applied yet. And then the adversarial prediction here, as we have, is when we've made the distortion to the sample image in order to trick the AI model. And then we go ahead and plot the original image and then the distorted image alongside the prediction of the neural network or the CNN model. So we'll go ahead and hit enter. And as you can see here, the original image says 7, and to the human eye, we can see 7 here. But then, after applying FGSM and then allowing the model to predict, it predicted 3 instead of 7, even though it looks as though it's 7 to the human eye. But we've been able to trick the model using this adversarial attack, using FGSM to make the model make wrong decisions. And this has many implications. So you can imagine autonomous vehicles that can be, compromised by attackers to make wrong decisions, or even facial recognition bypass that can be applied in various places such as operation centers, even airports. So here you go, guys. This is how you can basically use the FGSM method or adversarial attacks to trick AI models into making wrong predictions. Please, if you've enjoyed this video, if you learned a thing or two from this video, please like the video, share, and then comment your thoughts below. Otherwise, see you in the next video.